All right, so let's start here by filling in the factor theorem statement. So what this says is that the expression x minus a is a factor of a polynomial function if a is a 0. Now, a is just going to represent a number, so notice how whatever that number is, if you subtract that number from x, what it's going to do is it's going to make it look like it's the opposite sign as whatever the 0 was when it goes into the parentheses. So let's try a few problems here. This is going to be a way for us to work backwards, where we're starting with the zeros, we're starting with the x-intercept, and we're trying to figure out what is the polynomial function. The other thing you'll notice here is that we are doing these problems, we're getting them into standard form eventually, and so we don't want to have any parentheses in our final answer. However, using the factor theorem, we are going to start with parentheses to help us get the first step. Now, because there are 3 zeros here that are listed, I'm going to assume that they all have a multiplicity of 1 unless we are shown or told like that we have a repeated 0. And so each separate 0 is going to get its own parentheses. So initially writing it out in factored form, 3 zeros means I'm going to have 3 parentheses here side by side. Now every one of our parentheses is going to start with a single x. And the subtraction sign is part of the factor theorem process, so we could actually also think about putting a subtraction sign after every single x. Now what we're going to fill in behind the subtraction sign is the value of each of those 3 numbers that they gave us at the very beginning. Well, the first one was -2. Notice that when I plug that in here, I'm going to be subtracting a negative. So really, it's going to turn into plus. This is really the same thing as x plus 2. Now, this is not so surprising because it would make sense that if you had a 0 or an x-intercept of -2, when you put it into a parenthesis with the x, it looks like it turns into the opposite sign, right? If we saw this and we were trying to graph it and we were trying to get the x-intercept, we would say that looks like a +2, so to get the x-intercept, I'm going to turn it back into a -2. So that would make sense. Let's look at the next one here. Next we have a +3. Well, when we subtract that from x, it's just going to look like x minus 3. And then we have a +4. When that gets plugged in, it's going to look like x minus 4. So the general way that every parenthesis starts with the x and the minus sign, that's always the same. The only difference is what numbers are we filling in after the minus sign. Also notice that the +3 and the +4, when that went into the parentheses, it looked like it changed. It turned into -3 and -4. Okay, this is our polynomial in factored form. We are now going to multiply this out so that we can get it into standard form. And that's all we need to do. We just don't want to have parentheses in our final answer. So what we're looking at here is a binomial times a binomial multiplied by another binomial. We're going to actually need to do this multiplication in 2 steps. And I just usually like to think about going from left to right. I'm going to start to think about just multiplying the first 2 binomials together. And we've seen this before. We did some work with this first semester. We can multiply those 2 together with FOIL. So all of the focus is right now here in this red box. We are going to come back to that piece at the end, but we're going to do the other part first. So when we are doing FOIL here, I am doing the first term multiplied by the first term. Well, x times x is x squared. Then I'm going to multiply the outside terms together. So that's going to be x times -3. The inside terms will be +2 times x. And then the last term times the last term is +2 times -3. That turns into a -6. Now, I'm running out of space here, so I'm going to continue off to the side. I'm going to rewrite this, but I'm going to combine the like terms in the middle as I'm rewriting this. So I'm going to say x squared minus 3x plus 2x. Well, that's just minus 1x. And then we still have the minus 6 at the end. Now, I don't want to forget about the x minus 4. And so I am going to put the x minus 4 in the parentheses behind the result of my FOIL. And I still need to multiply these together. And so I'm going to put the result of my FOIL in another parenthesis. Those parentheses touching indicate that those two expressions, those two pieces, are still being multiplied together. Now this is a new one. We haven't yet done a trinomial times a binomial. We don't have a special acronym for it, let's FOIL, but it's very simple to catch on to. What I want you to think about is we are going to do the distributive property. We're just going to do it 3 times. So we are going to take each term from the trinomial. We're going to go in order, so we would take the first term here. That is going to multiply by both of these. Then we're going to take the term in the middle, and that's going to multiply by both of those. And then we take the term at the end, and that's going to distribute and multiply both of these. There's going to be a total of 6 little results here. It's just distributing each piece from the first parentheses by each part of the second. So here's what that looks like. You don't have to draw all of these arrows. I like to draw them, though, especially at first, practicing this to show what's happening. Now let's think about this first multiplication. So here we're doing x squared times x. So x squared, that's really x times x. Well, if I multiply that by another x, now I have 3 of them. If x is multiplied by itself 3 times, I get x to the 3rd. X squared times negative 4, this one's a little bit easier. It's negative 4x squared. Okay, let's think about the next piece. So now we're going to do the next term in the trinomial part, and I'm going to switch colors here. That is going to distribute to each part in the parentheses. Make sure we attach the negative to it. So first we have negative x times x. Well, anytime we have x times x, it becomes x squared. A negative times a positive is a negative. So that's that next result. Let's be careful with the negatives here. Negative x times negative 4. Well, that's going to turn into a positive 4x. All right, the last set of the distributive property here. We're going to do negative 6 multiplied by both parts. I have to make those arrows really big so they don't get confused with the others. So the first one here, negative 6 times x. We have negative 6x. Then when we're doing negative 6 times negative 4, it is plus 24. All right, so those are the 6 results of our multiplying. The last and final thing we need to do here, we're going to look for like terms. Like terms is when the variable part is exactly the same. And all we do is we add the numbers in front, and we keep the variable part the same. So for example, I have 2x squared terms. I don't have any other x cubed terms, so I'm going to actually keep the x cubed at the front, no changes there. But I'm going to combine these two in purple. Negative 4 plus negative 1, well, that's just going to turn into negative 5, and I'm going to keep the x squared behind it. We also have like terms over here, because it's both x to the first power. 4x minus 6x is minus 2x. We don't have anything for the 24 to combine with, but we are going to keep that 24 on the end. All right. Oh, I've got to make one other change here. This is our final answer. The part I forgot to do is we still want to have a y equals in front because we are representing an equation for a polynomial. Starts with a y equals. Notice that, yes, now it is in standard form because we have no parentheses going on. So the directions here are very similar. We're going to write a polynomial in standard form. This time the zeros are 0 and another 0. It's repeated. And then we have a 1, and then we have a -2. Okay, so initially, because we have 4 numbers listed out here, I'm going to start the same way. I know that each one of those zeros is going to be a factor in parentheses, so I'm going to set up 4 parentheses. And I'm going to start each one in the same way, x minus, they're all going to have an x minus in front. Now I'm going to start going through zeros in my list. So my 0 of 0, I'll go here. I have another 0 of 0. It's repeated, so I'm just going to list it twice. Then I have a 0 of +1, so that goes here. And then I have a 0 of -2. So notice how right now what I have in blue, that's just exactly the same as what they told us in the directions. Now we get to rewrite this and make it look a little simpler. So for example, the first piece here, well, x minus 0, that's just the same thing as x. So this is actually just x. And the next one here is also x. Now I still want to show that they're being multiplied together, so I'm going to use a little multiplication sign. My x minus 1 is fine. Let's change this to x plus 2, because we're subtracting a negative. Now the only other thing I'm noticing here is, well gosh, instead of writing x times x, a faster, shorter way to write that would be x squared. So this is a really nice version of our polynomial in factor form. Now notice how this one is a multiplicity of 2. When you have a multiplicity of 2, it just means this. It just means that you have a repeated 0. On the graph, we know a multiplicity of 2 means that it's going to bounce at that x-intercept. Lots of connections here. All right, we do still need to go through a process of multiplication because we don't want parentheses in our final answer. However, this multiplication is actually going to be easier than what we did in the first problem. If we still think about grouping these together and just do the first factor part multiplied by the second factor, we don't actually need to do FOIL here because this is not inside of a parentheses. Actually, all we need to do here is just the distributive property. So we'll just multiply x squared by each part in the parentheses. X squared, multiply another x on the end. We're going to have x times x times x, so that's going to be x to the third. X squared times -1 is -1x squared. Now I still want to show that it's being multiplied by the x plus 2 factor. And so I'm going to add in those parentheses again around the result of the first part. All right, now to finish it up, it looks like a binomial times a binomial. So we're going to be able to finish this one up with FOIL. All right, so let's think very carefully about all of these multiplications. So let's look at the first one, the first term times the first term. We have x to the third times x. Well, we have 3 x's being multiplied together. Now we're multiplying it by another x. So now it's going to be x to the fourth. So when you're multiplying x terms by other x terms, just think, like, how many x's are really in a big string being multiplied together? And that's your exponent. Let's do the outside term. So on the outside, we have x to the third times +2. That one's a little easier. So that's just 2x to the third. On the inside here, we have -x squared times x. Well, first off, negative times a positive is negative. We had an x squared. If we multiply another x, now there's 3 of them. So this is x to the third. And then finally, the last term, negative times positive is negative. It's basically 1 times 2, negative 1 times positive 2, which is going to be a negative 2 in front of an x squared. Okay, we're super close. The only thing I'm noticing here is we do have some like terms in the middle that are both x to the third. So let's add the numbers in front, positive 2 plus negative 1, or just 2 minus 1. That's positive 1. Keep the variable part the same. And that's our final answer. You can keep the 1 in front of the x cubed, but you don't have to. You could just write it like this. Any questions on this one? Okay. Let me give you a little direction. Okay, hold on. I'm going to stop and pause the video.